Hello everyone. We're going to start to introduce the topic acid and base. So let's start off by learning about the definition. The definition of an acid in accordance to Bronsted-Lowry is a proton donor. So you can see in these equations, the Ha actually donated the H+, which is the proton, to actually water to become H3O+. So hence Ha is defined as an acid or Bronsted-Lowry acid. In the case of NH3 or ammonia, it actually accepts a proton from your water. So in accepting the proton, you become NH4+, and therefore NH3 is defined as a Bronsted-Lowry base. The next term that we want to introduce is the word conjugate. When you look at any of the species that's been termed as conjugate base or acid, they are always on the right-hand side of the equation. And in this case, for A-, it's because Ha, the acid, has lost a H+ or proton to water, therefore becoming an A-, and hence is a conjugate base because it now has the ability to actually accept a proton. So base is defined as proton acceptor, acid is defined as proton donor. And you can see that in NH4+, because NH4+ has a proton H+ that can be donated, it is therefore a conjugate acid since the NH4+ is on the right-hand side of the equation. We also now want to add on that there's actually two further definitions for acid. One is termed as Lewis acid, the other one is termed as Arrhenius acid. We start off with Lewis acid. It's defined as an electron pair acceptor. All right, so it's opposite from Bronsted-Lowry in terms of definition. It's an electron pair acceptor. So in this case, as you can see, the H+ here actually accepts the electron pair from water. So hence Ha is defined as a Lewis acid. In the case of ammonia, it's a Lewis base. So Lewis base is defined as an electron pair donor. So you can see that it donates its electron pair to receive the H+. All right. So why acid and base definition did not go in accordance to Lewis' definition is precisely because that based on these definitions of electron acceptor, compounds like, for example, your AlCl3, okay, this compound would have been defined to be an acid, which cannot be correct because it is not an acid on its own. It doesn't have a proton, all right? It's not able to donate proton. And quite clearly, AlCl3 is not an acid. So based on the definition of Lewis acid, which is an electron pair acceptor, AlCl3 is able to receive an electron at the aluminum. So this means that AlCl3 is categorized as an acid, which is clearly not correct, which is the reason why the Bronsted-Lowry definitions of acid and base is the one that we're studying, as it is more accurate. Finally, why Arrhenius definition is not used. Arrhenius defined as acid that actually give out H+. Okay. This would have been fine for Ha, but in the case of Arrhenius base, it is defined as a compound that can release OH-. In this case, obviously, it can't produce OH-, as NH3 did not have any OH group of atoms with it. All right. With that, we end the portion on the definition. Thank you.